Hi everyone, welcome to my channel Big Bang Chemistry, a complete solution of the chemistry. In the series of the video lecture of molecular symmetry, today we are going to discuss the calculation of number of CN operation about a given axis of rotation. So before understanding the number of operation about a given axis of rotation, we must understand the two basic concepts. The first concept is CN operation raised to the power m. The first concept is, what is the meaning of Cn raised to the power m? The meaning is that we are doing the m times Cn operation. What is the meaning of this m times of Cn operation? If you are getting C3 first, C3 raised to the power 1, meaning is that we are doing the C3 operation one time. If C2 raised to the power 2, meaning is that we are doing the C2 operation two times. If C3 raised to the power 3, meaning is that we are doing the C3 operation 3 times, right? But very important concept is that if number of operation is equivalent to the what? Order of the axis, meaning is that Cn raised to the power n. What is the meaning of this? Meaning is that whenever you will perform this Cn operation n times, then you always get the what? Identity operation. Identity means what? Equivalent, not equivalent, identical geometry you will get, right? Meaning is that if you will perform a Cn operation n times which is equal to the what order of axis, then every time you will get the identical geometry which is identical to original geometry of the molecule. So meaning is that C2 2 times identity, C3 3 times identity, C4 4 times identity, C5 5 times identity operation. Every time you will get. Concept number 2. What is the meaning of number of equivalent operation? How to calculate the total number of equivalent operations? So there is a formula n minus 1, right? So now question is that how to apply this concept in any type of molecule, right? So let's check the example of Ab3L0 type of molecule, right? Again, this molecule is having trigonal planar geometry. The structure of this molecule is this. Now in this molecule, total two different type of proper axis of rotations are present. The first 3 C2 is visible for me, so just I mark it with this line, right? So this is your one C2 axis, this is your second one, this is your third one, and this molecule is planar, so all the C2 axes are present into the plane of the molecule, right? And there is a one C3 axis present in this molecule, so we are trying to show the C3 axis by this line, right? So what is the meaning of this C3? C3 is perpendicular to the what? Molecular plane, perpendicular to the what? This triangle, right? And passing through the what? This A. Now question is that how to visualize this two different type of axis of rotation. For the visualization, we are taking the help of one 3D structure of Ab3 type of molecule. Now observe this structure carefully, right? In this structure, this line, this is what? Molecular plane, right? What is this? This is the molecular plane. In this plane you are keeping your triangle, this is your triangle, and then this is your C3, right? Now try to see all the C2 axis present in this molecule, right? See that this is one C2 axis, this is another C2 axis, and this is the another C2 axis, right? So these are the C2 axis present into the plane of the molecule, right? So now I can say that everyone is able to visualize all two different type of axis of rotation present in this Ab3L0 type of molecule. So now we are going to perform some operation about the C3 axis, right? To understand the basic concept, concept number 1 and concept number 2, right? So now take the example of this molecule Ab3. So in Ab3L0 type molecule, all the B1, B2, B3 atoms are equivalent. Only for our own understanding, we are marking as a what? B1, B2, B3 equivalent to the B. Now perform the C3 operation about this axis, C3 axis, right? First time, the first C3 operation. So when you will do the C3 operation about this axis one time, meaning is that we are rotating this molecule about this axis at 120 degree. So when we rotate the molecule about this axis at 120 degree, then what will happen? So this B1 will interchange its position with B3, this B3 will interchange its position with B2, and B2 will interchange its position with B1. So after this operation, what are the new position of these B atoms, right? So the new position of B atoms are what? Here B1 will come, here B3 will come, here B2 will come, right? So what is the meaning of this? C3 operation one time, right? So this is the structure number 2 and this is the structure number 1, and this structure number 1 is equivalent to the what? 2, or 2 is equivalent to the 1. So why? This is your what? Proper axis of rotation, right? Now again this is the C3 proper axis of rotation. Now again perform the C3 operation in this molecule, meaning is what? Rotate this molecule at 120 degree. When you will rotate this molecule about the C3 axis, then B2 will interchange its position with B1, B1 will interchange its position with B3, and B3 will interchange its position with B2, right? So after performing this C3 operation second time, right, what is the new position of all the B atoms? So the new position of all B atoms will be like that. B2 will be here, B1 will be here, and B3 will be here, correct? Now again perform one more C3 operation in third structure, in third geometry, right? So now again we will rotate this molecule at 120 degree and perform the C3 operation here. So now when you will perform this C3 operation third time this molecule, then what are the new position of the B atoms and what will happen the B atoms? This B3 will interchange its position with B2, this B2 will interchange its position with B1, and this B1 will interchange its position with B3, right? These are the position of all the B atoms, right? So this is the position of B1, this is the position of B2, this is the position of B3, right? So this is what? C3 operation, how many times? 3 times. So now we can write this one, Cn perform n times. Now when you will perform any Cn operation n times, you always get the what? Identical geometry, right? So now compare the structure number 1 and structure number 4, right? So when you will compare the structure number 1 and 4, then you will find structure number 1 is totally identical to the what? Structure number 4. So meaning is that after performing Cn operation n times, right, you will get the identical structure. So this is what? C3 perform 3 times, then directly you will get this structure. But what about this second and third structure? Check that. When you want to convert this first structure to the what? Third structure, that time you need to perform C3 2 times in structure number 1, then you will get it, right? So now check, this structure number 4 is identical to the what? Structure number 1. So Cn operation is giving you what? Total equivalent geometry of the molecule. How many equivalent geometry of the molecule? 2 equivalent geometry of the molecule, right? So these are the what? Equivalent geometry, right? And for getting the equivalent geometry, how many number of equivalent operation we are performing? Out of 3, 2. Meaning is what? 3 minus 1. Meaning is what? 2. Meaning is that about C3 proper axis of rotation, when we will perform 2 C3 operation, then we will get the what? 2 equivalent geometry. So what is the number of equivalent rotation, n minus 1, n is what? Order of the axis 3 minus 1, which is 2. So I hope that everyone is understanding the meaning of Cn raised to the power n, what is the meaning of this formula and what is the meaning of this formula, right? So in this molecule, just we calculated the number of equivalent operation, right? Only for your understanding what is the meaning of equivalent operation, right? But in a given molecule, how many total equivalent operations are present, right? About all the proper axis of rotation. We will do this discussion in the next video.